the law, unless for real. All right, we're gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9 variations of the main trigonometric identity. What's the main trigonometric identity? Rue. Go for it. Write it down. We did do it last semester, which I know was eons ago. It was not a year ago. It was last year. It was last decade. You're right. You're right. Okay, so we're going to prove. Shh. Okay, stop. Don't memorize it. You can derive the main identity, which is sine squared plus cosine squared is 1. And when you derive that, the remaining 8 variations all flow. In a circle, some angle theta, doesn't matter. Hypotenuse is 1. Yes? Okay, so generically speaking, x, y, agreed? All right, I'm going to erase half of this as we go, but it doesn't really help us. There's no trig involved in x or y. So instead of using x and y, what can I say? Cosine and sine. So x is cosine of theta. Don't forget your angle. Yes? There it is. Pythagorean theorem. Pythagorean theorem, a squared plus b squared equals c squared. Agreed? Okay, so the sum of the squares of the lengths of the sides of a right triangle is equal to the square of the length of the hypotenuse. So instead of using a and b, what can I use? Sine and cosine. And then 1. Eventually, like legitimately, we're going to do 25-ish identities down the line. You will be given an identity sheet down the line. You will never be given that sine squared plus cosine squared is 1. It is the most important identity in trig. Okay? All right, so let's do let's do the first variation. So let's say I want to solve for sine or I want to solve for cosine. Help me out. Where do I go? If I want to isolate sine or cosine squared, pick it. Okay, so subtract. You don't subtract 1. You subtract 1 and then pick one. I hear sine and I hear cosine. Cosine. All right, so if I want to isolate cosine squared, this is pretty basic. You should subtract sine squared. Okay, so there's a variation. That's it. Yep, that's it. But the more important part comes next. That can be broken down. You can break that down. How do you break down 1 minus sine squared without using opposite hypotenuse and all that stuff? Yeah, JC. Difference 2 squares. You got it. Factor it. Factor it. That is factorable. It's difference 2 squares. Perfect mathematical language. Thank you, JC. Oh, yes. Oh, yes, yes, yes. What? You have to have theta in both sets of both quantities, because theta times theta is, right, sine squared. So here we go. This is the same thing as quantity 1 minus sign or plus sign, doesn't matter which one comes first, and then 1. Okay, so there's 3 of the 9. Yeah, we're going to do 9. 1, 2, 3. Yeah, that's 2. 1 minus sine squared, which is transitive property, yes? A equals B equals C, then A equals C. All right, so you guys were debating which one we should do first, and you said cosine squared, so now do the variation with sine squared. Now do the variation with sine squared. Yeah. And then we're going to go straight into that fifth. It's the mic. What do you mean? Oh, no. It's not a speaker for you guys. It's a video, essentially. It goes straight to a YouTube channel. No, well, maybe. Probably not. And we're not going to shout and try. And we're on video, so how about we do the problem? If you want to have, like, your day in the sun, you're going to have to sign a waiver. I bet you they can hear me slurping my coffee. What's that? Huh? What are you talking about?
It's like surrounding.
Put the mic like right here.
Put the mic really close and then make like noise. Here and then gulp.
The students like that. That's how you do it. That's how you go. Okay, anyway, they're going to be like, Miss Babiak, you're supposed to be teaching trig, not talking about gulping. All right, here we go. Sine squared theta equals 1 minus cosine squared theta, which equals?
1 minus cosine theta quantity times 1
Oh, yeah. I always do plus first, always. So then I got messed up. This is 4 and 5. 4, 5. So I lied. We're only going to do... Oh, no, we got a lot more to go. Okay. Great. I circled them. You need to know them. Actually, that's not true. You need to know sine squared plus cosine squared is 1, because then you can derive the rest. All right, so now... Stop. Let's talk about secants and cosecants and tangents and cotangents. So let's go back to sine squared plus cosine squared equals 1. I'm just going to rewrite it. It doesn't count as another one. I'm just rewriting because we're going to do some manipulations of this identity. We're going to do more manipulations. So I want to do some cosecants squared. I want to do some secants squared and tangents and cotangents, blah, blah. Where do you recommend we go? Yeah, Ishika. Okay. Oh, you want to write it as 1 over... Stop. Thank you. Okay, so sine squared is... We usually don't. Is that true? Sine squared and cosecant squared, they're reciprocals. This is like old news. Stop. Cosine squared. 1 over secant squared. 1. Can we like rewrite 1 using sine over sine? Cosine over cosine? Yeah, but I wanted to include some tangents in there. So I think that this is a good place to start, but it's not going to be the most helpful, and that's okay, because you know what? When we're starting to do identities tomorrow, we're going to make a lot of mistakes, and we're going to do a lot of erasing. So, Ishka, that was a great thought process. Not exactly going to get me where I want to go. Yeah, Rue. Oh, but if I divide the right side by 1, or by sine squared, what do I have to do the rest of it? There we go. So let's divide everything by sine squared. Is that allowed? Of course it's allowed. I'm performing the same operation. Turn the phone off. Simplify. I don't know how it all works. Say it again. No, I've done 3 or 4, 5 in algebra 2. Not in this class. Sine squared over sine squared. 1 cosine squared over sine squared. Cotangent squared, fantastic. And 1 over sine squared, cosecant squared. And there is another variation. 6, that's 6. We're going to do 2 variations. There are 2 variations. No. We're not dividing by cosine squareds yet. That's going to come in a minute. There are 2 variations of 1 plus cotangent squared. You just did it with different functions here in the pink and the blue. Find the variations. There's 2 of them.
Like using cosine?
No. That we're going to... I want you to use the equation 1 plus cotangent squared equals cosecant squared and do the subtracting and the factoring. I subtracted incorrectly. Yeah, it should be the other way around. It should be cosecant squared. Better? Factor it. Difference 2 squares. What we got here? Are you looking for something to eat? We were foraging. You guys use such big words. How'd I do? I mean, why did I use cosines here and use cosecants here?
Well, no. Like, why did you use, like, why is it 1 plus cosine?
Because this is difference 2 squares. This is a squared minus b squared, which is,
Oh, it's
and then instead of a and b I used, yeah? Yes, Rue. Yeah. Uh-huh. There's so many variations. This is one of them. My point is, you really need to know how to factor with difference of two squares. You really need to know how to factor with difference of two squares. It's of all the factoring, in my opinion, it's the most important, and it shows up more than any others. Any other patterns? Difference of two squares is everywhere. Yeah, Val. Well, yeah, of course. This is 7 and 8. I think I lied. I don't think they're 9. I think they're 11. No, it's a 7 and 8. Who cares? 1, 2, 3, 4, 5, 6, 7, and 8. What? It doesn't matter how many there are. You need to know them. That's not true. You need to know sine squared plus cosine squared is 1, because then you can derive all the rest of them. Yes, Ryan? Oh, you could do it that way too. That's what Rue was asking. You can absolutely do it that way too. All right, divide by cosine squared. Go for it. Yeah, that's totally okay, Ryan. I don't know why I did it this way. Just come on, divide by cosine. You all. The original, the primary identity. Well. Do the whole thing. Do the variation. Do the, you get the basic equation, 1 plus blah equals blah, and then do the factoring and compare with your neighbor. When we do identities starting tomorrow, and I say proof, but it's not the kind of proof that freaks you out from geometry. Mr. Martinez likes his proofs. Sounds like heaven to me, but okay, I'm a math teacher. What do you get? What do you get? What do you get? I didn't hear a lot of comparing with neighbors. Compare with neighbors. Good job. I listened carefully, and I may have heard one or two tans in there, but for the most part I heard tangents, and that's good. We use tangents in cot. Ay, ay, ay. Cot is definitely not a proper trigonometric term. No comment. All right, sine squared over cosine squared. Tangent squared plus 1 equals secant squared. Fantastic. Subtract, factor. A couple ways you can do it. Subtract and factor. You can subtract the tangent squared. You can subtract the 1. And I should have in the previous, in the one in green, I probably should have subtracted 1 instead of subtracting the function, but whatever. How many of you subtracted 1? Okay, how many of you subtracted the function? That's probably because I did it that way last time. It makes no difference. So if you subtract 1, what do you get? Secant theta plus 1, secant minus 1. Well, no, they're different functions. If you subtracted, instead of subtracting 1, if you subtracted tangent, if instead of subtracting 1, you subtracted tangent, what do you get? Okay, they all work. So we are not going to be doing a ton with the identities today. We will be doing. Find the period of a sine or a cosine function. 2 pi over b. How do you find the function? Pi over b. Okay. Here we go. We're going to solve so new dealio. Pardon me? Well, I haven't given you the problem. How do I start? Where should I start? Martin? Oh, okay. Let's see about that. So Martin says add 1 to both sides. So we can try and use some of these identities. Not a bad place to start. I didn't even think about that. Great. And I think it'll work. Yeah, Ethan. Okay. So this is good. Or square root. The tangent of theta is 1 over root 3. Square root both sides. Is that legal? Of course it is. Square root both sides, you're great. Add 1 to both sides, great. We're going to do both ways. Yeah, Rue. Okay. So let's stick with Martin's option. What is tangent squared plus 1? Secant squared theta. All right, so let's see where this takes us. 4/3. Because it's an identity right here. Tangent squared plus 1 is secant squared. Now what? Square root both sides. So either way, eventually, you're going to go down the square root path. So this is the secant of theta equals 2 root. What? Square root both sides, and you get 2 over root 3, which rationalized is 2 root 3 over 3. Agreed? Okay, so I recognize the root 3 on my unit circle. Root 3s are some variation of a 30/60. Let's stick with radians. Pi over 6, pi over 3. But you guys are forgetting something very, very important. Sarah. Woohoo! Ding, 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 ding. Plus or minus. Okay, you're going to get the same answers either way. Personally, I don't know the secants off the top of my head. I know the cosines and the sines for the most part, but I don't know the secants. Maybe you do, and that's awesome. For me, I'm going to rewrite this as, instead of saying the secant of theta is 2 root 3 over 3, I'm going to go with the cosine of theta is plus or minus root 3 over 2. I recognize it, so I hope it's right. You're going to get the same answers either way. When you rationalize, you get plus or minus. Same answer, either way. Figure it out. Your unit circle, it is never going away. The unit circle in your math life is never going away. Figure it out. Compare with your neighbor. It's both. It's both. It's a pi over 6 reference. Compare with your neighbor. Yes, Rue. I rationalized. Good. I see lots of conversations. Aaron, you need to participate. You're in big kid math now. Let's go. Well, you were before. Now it's even bigger. Oh, I hear great. It could also be negative pi over 6. Maybe. Give me a reference angle. It's either pi over 3 or pi over 6. Pi over 6. So the reference. Yes? Okay, so that's first quadrant. That's also, well, there's pi over 6 in every quadrant. So the question is, what's a pi over 6 reference in quadrant 2? What's a pi over 6 reference in quadrant 3? What's a pi over 6 reference in quadrant 4? You should have 4 answers. Ashwin, did you have a question? Okay, so what do we got? Pi over 6. 5 pi over 6. 7 pi over 6. 11 pi over 6. 4 answers. You could keep going, but you read the directions, and the directions say from 0 to 2 pi. Yeah. Not with the unit circle, because it's 2 possible answers between 0 and 0 and pi. It depends if it's sine or cosine, if it's tangent, cotangent. Because it works in all 4 quadrants. All right, let's up the ante. Let's up the ante. I'm going to change the directions after I write the problem down. Cosine of theta is negative root 3 over 2. And I want how do they write it? Okay, so I want you to write a general solution. What's that mean? Say it in a second. After we do the whole problem, it'll make more sense to you. These are the directions the book uses, and so I want to make sure that we go over it in class. All right, reference angle. That's pi over 6 again. The reference angle is pi over 6. Aha. So this is where you got to be careful. The answer is pi over 6. This is not the same as the inverse cosine of negative root 3 over 2. These are not the same. This is involving an inverse. And the range of the inverse cosine is 0 to pi, which does fall between 0 and pi, by the way. Oh, no. I lied. I sort of lied. So the reference angle is pi over 6. What's the actual solution? Give me a solution. 5 5 pi over 6? Okay, so there's two answers. 5 pi over 6 and 7 pi over 6. So hold on. Let's just stop there. Cosine is negative, quadrants 2 and 3. Agreed? Cosine is negative in quadrants 2 and 3. So here's the quadrant 2 answer. Here's the quadrant 3 answer. But 7 pi over 6 falls outside of the range of the inverse cosine. There's no inverse cosine here. This is not the same. So this part, what I wrote, is true. This is not the same as the inverse cosine of negative root 3 over 2. This has one answer between 0 and pi. No inverse here. I'm just solving over the unit circle. Inverse. No inverse. They are different. The answer to the second part here is only 5 pi over 6, not 7 pi over 6. For the inverse, only 5 pi over 6. Because the range, if you, I can't draw it, but remember how we did for sine, it looked like that, and it was only in quadrant 1 and quadrant 4. And then the cosine one looks like this, I want to say. Okay, not the same. But we're not done. So I want a general solution. So this is a solution from 0 to 2 pi. I'm asking you to solve from 0 to 2 pi, you're done. I want a generic solution for around and around and around and around and around. How much in the around? How much is it around a unit circle? 2 pi. So write a solution expressing my answers as I go around and around and around and around 2 pi. Because it's 5 pi over 6, but if I go around again, it's 17 pi over 6. You got to do that k thing. Yeah, figure it out. You have to do that k thing. K is a constant. K represents how many times you're going around. Nope. How many times is around? What's the length around the unit circle? So you're going to add 2 pi, add 2 pi, add 2 pi, and that will continue to give you a correct answer. Well, I don't want to keep doing this. How many times should I add 2 pi? Once, twice? As many as I want. How do I indicate that? K. K. No. So, 5 pi over 6 plus 2 pi k. What did we do that for? I don't remember what we did that for, but we've done it. The domain of the tangent. Range of the tangent. Yeah. Or 7 pi over 6. No, they'd be both. Yeah, and. Yeah. I don't like that. You're leaving off something super important. What is k? Yeah. Where k is what? Because I'm not telling you if it would be an integer, because you could go backwards. There's no restriction on what the directions say. So we would just say integer overall. Well, it says write a generic equation, so that's what a generic equation would be. Going forward, backward, whatever. Tangent 2 theta equals 1. And we're going to solve from 0 to 2 pi. How do you know where you're supposed to solve? How do you know, like, how far you're supposed to go and what you're supposed to solve? It's a trick question. Read the directions. How do I know if I'm supposed to add the k or if I'm supposed to stop at 2 pi? I'm going to read the directions. tangent of 2 theta. It's not tangent squared. If it was tangent squared, it'd be great. Square root both sides. Square root of 1 is 1. It'd be a lot nicer. Nope. It's voodoo math. You cannot divide by 2. Yes? Try to, oh, Ishika, you're on fire, man. Try to write 2 theta using a different variable. So, what do you want to use? Pick a, like, x, y, z, a, b, c, p, q. X? I heard x. I heard x. Remember we did this with the e to the this, and remember we did that? Oh, do you want to close the blinds? Aaron, take the other one and just pull the ropes. No, pull the. Better?
Yeah.
You sure? Here, let's do this as I reach over everybody's desk. Sorry. Yuval, would you stop? I don't need a comment after everything I do. Okay, so if 2 theta is x, then I can say the tangent of x is 1. All right. What angle has a tangent of 1? Pi over 4. Yeah, 45 degrees, which is pi over 4. All right. So x equals pi over 4. There's another place, because we're going to 2 pi, so I can give the next measurement. Pi over 4, 6 pi over 4, 18 pi over 4. Let's get an answer. 5 pi over 4, third quadrant. Tangent is positive in quadrants 1 and 3. Yes, Ethan. Oh, because I just know my unit circle.
Okay, but like how I like to think I need to do for not understanding the connection.
Got it. No, that's fantastic. I appreciate the way you said that. So I've got in positive, positive, negative, positive, negative. Yeah? Tangent is y over x. Tangent is sine over cosine. So in the first and third quadrants, so that's how I know it goes in first and third. Okay, next. Yeah? Okay, and so then if you're going to get 1, any number divided by itself, any variable divided by itself, okay, except for 0. Any number divided by itself, any variable divided by itself is 1. Agreed? So if I'm going to get 1 for my tangent, then my opposite over my adjacent, or my y over my x, have to be the same. And the only way that's going to happen is if it's root 2 over 2. Root 2 over 2 over root 2 over 2 is 1. So it's a 45 degree. Yeah, tangents take a lot longer, for me at least, tangents take a lot longer to learn. All of them except for sines and cosines, I'm still like. We're not done though, this is not the answer. We're not done. We started with let 2 theta equal x. So here's what x equals. That's not what theta equals. So you got it. Oh, so that's an issue too. There's all these issues. We have to help solve the problems. That's our job. We're going to help solve problems. That's our job. You know how many problems I solve every day? I'm a fantastic problem solver when I do it right. Okay, so theta equals pi over 8. And theta equals 5 pi over 8. Oh, but you're not right. No. No, you divide by 2, you get pi over 8. What about 11 pi over 8? more problems. This problem has many, many issues. We're about halfway done. 3/4. Is that right? How can I tell if it's right or wrong or whatever? Plug it in. Check. If theta is 11 pi over 8, check. Do I actually get 1? Check. Do it with your neighbor. Do it on your own. Whatever. Check. 11 pi over 8 is not more than 2 pi. I'm asking you if it works. Oh my God! You put your calculators away! It works. Because I'm an amazing problem solver.
Without using a calculator, I can figure it out. I mean, you have a 50% chance of being right.
Yeah, but how do you know? I could have said 13 pi over 8. All right, so let's check. The tangent of 2, I'm saying 11 pi over 8. Does that equal 1? I'm checking. I'm plugging in. How do you check? You plug in. Theta is a variable. Well, it's an angle, but in this case, it's a variable. Plug in. This gives you the tangent of 11 pi over 4. I multiplied 2, and I believe that the tangent of 11 pi over 4 is 1. Do you agree with that? Okay, so here's the other issue. Okay, so we're not dealing with different quadrants because we're not doing an inverse. Oh, but Miss Babiak, 11 pi over 4 is more than 2 pi. So that can't work, right? 11 pi over 4 has a tangent of 1. 11 pi over 4 is more than 2 pi. Can't work. It does. Rue. Yep. What did I plug in? We solved and we said theta was boom and boom. And I'm telling you, 11 pi over 8, is that less than 2 pi? There's another answer less than 2 pi that also works besides 11 pi over 8. Figure it out. I'm going to get there. I want you to figure it out. I got 11 pi over 8 because I've done the problem a gazillion times and I know. I want you to figure out the other answer. Tangent of 11 pi over 4. You're right. How about 13 pi over 8? That's 15. Thank you, Mukundin. I messed up. See, you all believed me. And now I'm on video making all these mistakes. It's like, oh my word. I messed up. It's your fault. You didn't tell me until after all of this that it didn't work. It is. You know what? You guys have to learn how to misplace blame. Then it's like, I got to be careful what I say. 10 pi over 8 is 5 pi over 4.
14.
What's going on? What's the issue? I said 13. You said 15. I'm not listening to Mukundin. He keeps giving me all this like false information. Tangent of 2 theta. Oh, because I wrote it down wrong. Okay. 13?
Well,
He said 15, and I wrote down 15.
because I mixed it up because it's over 8 and over 4. I multiplied it by 2 times.
believe. I don't believe me.
It's 13 pi
It
over
has to
8.
be 13. It's gotta be
13 is 13. Yeah, shouldn't it be consistent? Wait, so there's 13 and then you said there was another one?
Yeah, there's 4. You add pi over 2 times 8. 8 plus 15 is 13. Okay.
13 pi.
So,
Not easy. Times 2. Tangent. Well, just 5 pi over? No, 13 pi, that's not equivalent to the amount of degrees. 40. 13 pi is not 40 degrees. That's yeah. 13, no, you're in like the wrong, you're doing it,
You're right. That should be.
just convert it to degrees then.
that might be easier for some of you.
13 pi.
I don't believe any of you.
I believe it.
Where's okay, you know what? Let's draw it.
Convert 5 pi to degrees.
13 pi over 4.
It's in the third quadrant.
13 pi over 4. 4, 8, 12, 13 is here.
Oh, yeah. Okay, 10. Yeah.
9 pi over 8. I think that's the other answer.
Because you go there by 4 every time.
Yeah. All right. So how do you get that though? How do you get that? So you said you're adding 4. Okay. So 9 pi over 8. Also works. Let's just go one step at a time. 9 pi over 8 also works. Okay. So you have pi over 8, 5 pi over 8, 9 pi over 8, and then what? 13? All right. So you're adding 4 each time? Apparently. So 17 pi over 8 should be the next one? Because it's more than 2 pi. Yes? Okay, but we have to figure out where did these come from. I promise I'm going to get you there. So if I was to keep going and going and going, I would have all this. Agreed? You would keep going and going and going? Yes? So this is the answer based on the directions. However, you would keep adding 4. You're adding 4. No, hold on. Stop. You're not adding 4. You're adding 4 to the numerator. You're adding, what essentially are you adding? To go from pi over 8 to 5 pi over 8 to 9 pi over 8 to 13 pi over 8, how much am I adding? I'm not adding 4. I'm adding pi over 2. Agreed? So this is, wait, stop, because this is how you find the remaining answers. Okay, so we are adding pi over 2 to get the next answers. Time out. Hold on. Do we agree that you're adding pi over 2? No. So to go pi over 8 plus x equals 5 pi over 8. Subtract. You get 4 pi over 8, which is pi over 2. All right. Yes, Rue. Here's how you figure out the remaining answers. You don't just get lucky and say, oh, I'm adding pi over 2. So, 15 minutes ago, 10 minutes ago, however many minutes ago. Yeah?
If the direction graph to make a general.
Then it would be plus pi over 2. Okay. I want to get to how you find those. Yes. Thank you! Ashwin, speak up. I asked you, what's the period of sine and cosine? And you said 2 pi. And then I asked you, what's the period of tangent and cotangent? And you said pi. B is 2. Therefore, pi over 2. There's what you add each time. I just couldn't add properly because I messed up the first one, which then, of course, messed us all up. Period matters. Rue. Because if B is 2, okay? So for this particular problem, if you have a graph, tangent, and you do where it's 1 and you cross here and there. Yes? Do you want me to draw like a real graph? I'll draw a real graph. Yes. Same thing with secant and cosecant. All right, let's draw a graph, see what it looks like. Let's draw a graph and see what it looks like. So, parent, tangent. I was talking to a teacher yesterday about, my student was doing so well. She had a solid B. They took the final. Now they have a C. What's going on? And the problem is you're memorizing. The period is this. Let's look at the graph and see what it really looks like. So if the period for tangent is pi, the period for tangent is pi. Agreed? Okay, but B is 2, so the period for this particular graph is pi over 2. Okay? All right, so I'm going to draw the parent, and then I'm going to adjust it. This is the parent. I'm going to adjust it. Oh my God. I need to go back to bed. The problem is I've only had like half a cup of coffee. See, I'm misplacing blame. I'm blaming the coffee. What did I do wrong? What did I do wrong with my graph? Tangent is... Tangent is... I'm glad that you truly understand what tangent means. Tangent is sine over cosine. Yes? See, I'm going to derive it because obviously I just messed it up. So, if cosine is 0, then tangent is undefined. And undefined on a graph is an asymptote with a silent P. Yes? Okay. So, where is the cosine 0? Pi over 2. Let's just draw a cosine curve. Okay, that's a cosine curve. I'm 100% positive that's a cosine curve. So, this is pi over 2. This is pi. 2. What's it look like in the middle? Function? Yes? Okay. This is the parent. This is the parent. Take all this off. Period is pi. Are we ready to move on? Okay. So, the period for this particular graph, for this particular equation, the period is pi over 2. So this should be pi over 4 and negative pi over 4. So this is pi over 2. This is 3 pi over 4. This is pi. Yeah? Okay, so continue the graph. That's not part of the, that's 13 pi over 8 is not what I'm asking. I'm not asking you to, 13 pi over 8 does not fall between 0 and pi. Yeah, it does. It doesn't fall between, oh no, it doesn't. Watch. Draw the graph. Finish the graph. What, Ishika? Period is pi over 2, divided by 2 is pi over 4. I'm graphing this one, but I'm not done. That's how you find the intervals. Tangent, the period, the parent function. So the period for the parent tangent is pi, divided by 2 because there are 2 quadrants between 0 and pi. Normally we divide by 4 if it's sine or cosine or yeah.
Oh my god.
Draw the graph. You guys are staring. Draw the graph. Participate. What's the next increment? 5 pi over 4?
Yes.
6 pi over 4, which is 3 pi over 2. 7 pi over 4, and 2 pi. So I'm going to stop at 2 pi because I've been asked to solve from 0 to 2 pi. 5 pi over 4, 7 pi over 4. I'm stopping at 2 pi, so I don't need the remaining asymptote. Like I don't need to keep going. Boom. Boom.
So for always work to 2 pi, does that mean that the negative pi over 4 pi?
I'm going to take it off. Exactly. Okay, so direction said solve from 0 to 2 pi. Okay, so we can get rid of all this. So I want to know where the tangent is 1. All right, so without my calculator, which you are not going to use. Great. 1 is here. Fantastic. One, 2, 3, 4 answers.
You add the little like thing to 2 pi, right?
No, I asked you to solve from 0 to 2 pi. Done.
Like is there like a line?
No, 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 no. So, yes, thank you. It's like, what's this, 9 pi over 4? No, because this is outside of 2 pi. But it's negative. I don't want negative. I want positive. correct. If they wanted negative, there would still be 4 answers. Boom, 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 boom. Yes, Rue. Yeah. Mm-hmm. There is why there are 4 answers. Okay. We still have several to do, so let's take a break. 19.
What possible answers do you compare as being 5 by 2, right?
Yes.
But that's not always true, correct?
That's not always true.
Okay, okay.
It's not true for sine, cosine, or
Oh,
right? But it is always true